Welcome to our lesson about exponential growth and radioactive decay. Exponential growth and radioactive decay are both belonging to the topic about exponential functions. Let's move to part 1, exponential growth. Exponential growth is growth that increases at a consistent rate. It is a growth that increases by constant proportion. The equation for exponential growth is y equals to c times e raised to kt, where y is the value to be found, c is the initial value, k is the growth rate, and t is the time. Note, the e in the equation is a constant known as the Euler's number, which has the value of 2.71828 ellipses. Example number 1. An amount of 1,000 pesos is compounded annually at 10%. How much money would there be after 5 years? Notes for success. C is usually the initial value of money or population. In problem solving, K is usually expressed in percent form, so don't forget to express it in decimals. T is time, which is usually measured in years. Here we can use the formula y is equals to c times e raised to kt and identify the values of c, k, and t. Based on the problem, we can find that c is equals to 1000, k is equals to 0.10, and t is equals to 5. Solution. Substitute the values in the formula. Simplify further. By plugging e raised to 0.50 into a calculator, we find its value to be 1.648721. Rounding to the nearest hundredth, we obtain the value 1.65. Then, continue the process. So that, therefore, we conclude that if an amount of 1,000 peso is compounded annually at 10%, there will be an amount of 1,650 after 5 years. In some problems, the equations to be used are already given, and the only thing to do is to substitute the given values for the variables involved. Let's take a look at the second example. Solution. Since the equation to be used is already given, we will just substitute 4 for the t in the equation and evaluate. Using the calculator, we find we round the value to the nearest hundredth and obtain 2.23, then continue the process. Therefore, there will be 223 of the certain bacteria present after 4 hours. Let's move to part 2, radioactive decay. Radioactive decay is the process by which an unstable atomic nucleus loses energy by emitting radiation. This belongs to the exponential decay, the opposite of exponential growth. Note, a quantity is subject to exponential decay if it decreases at a rate proportional to its current value. The formula is similar to exponential growth except for the negative sign of the exponent. Y is equal to c times e raised to negative kt where y is the value to be found, c is the initial value, k is the decay rate, t is the time. Let's take a look at the first example. The daily decay rate of neptunium-239 is given. We are supposed to find the remaining amount after 1 day. We have the following values. Solution. We will just substitute the values above to the variables in the equation. By plugging into a calculator, we find rounding to the nearest hundredth, we obtain the value of 0.73. Then we continue the process. Therefore, we conclude that after a day, there will be about 73 milligrams of neptunium-239. Now, it's your turn. Solve the following problems. Thank you for learning with us.